My name is Bijoy. Today I am going to discuss the internal structure of JVM. So first of all, what is JVM? JVM stands for Java Virtual Machine, which is written in C programming language. It is a abstract machine. It is a software execution engine which will execute the bytecodes in a Java class file on a microprocessor. A microprocessor may be in a computer or it may be in any electronic device. So you can say that JVM is an abstract specification where the bytecode can be executed. So let us see how does our Java code is executed. The first step, the C compiler compiles the JVM source, which is written in C programming language. Then it will retrieve jvm.exe file for particular operating system. The operating system can be Windows operating system, the operating system can be Celeron operating system, or it can be Linux operating system. In step 2, the retrieved jvm.exe file will process the bytecode, that is .class file. So what we have learned so far, the JVM is nothing but a C program which processes the bytecode into a machine readable language. So the Java virtual machine will expect a file which contains bytecode as input. Now let us discuss various components of JVM. We can divide the components into different layers. As you can see from the diagram, it is consisting of 3 different layers. Layer 1 contains class loader subsystem. Layer 2, which is runtime data areas, and the runtime data areas divided into 5 different subcomponents, that is method area, heap, Java stack, PC registers, and native method stack. And the layer 3, it contains execution engine, native method interface, and native method libraries. In the next slide, I have defined the layered architecture of JVM. You can refer this slide. So now let us discuss each area one by one. The first is class loader subsystem. So what is class loader subsystem? In the Java virtual machine, the class loader loads the class files, and it is also responsible for allocating the memory for the program. The class loader subsystem consisting of 3 different tasks. That is, first, it loads the .class file into memory. Second, it will verify the bytecode instructions. And third, it will allot the memory required for the program. We can have multiple class loader subsystem. We can have bootstrap class loaders, we can have extension class loader, system or custom class loader, or user defined class loaders. Now let's move to the next layer, that is runtime data areas. In runtime data areas, you can see 5 different subcomponents. First, method area. The method area will store the class code and method code. When the virtual machine loads a class file, first of all, it will parses the information about a type from the binary data contained in the class file. Then it will place such type of information into the method area. The next subcomponent is heap. Java objects will be created on heap. A heap basically a memory space which is managed by the operating system and also used by processes to get additional information or additional space at runtime. This heap area is a global area. That means any process can use it. The main functionality of heap memory is to provide additional memory resources to process that require supplementary space at runtime. Now, the next subcomponent is Java stack. Java stack is a place where Java methods are executed. A Java stack contains frames. On each frame, a separate method is executed. Like it will store the state of Java methods. It also includes local variables. It also contains method parameters. It also returns a value. And it also contains intermediate calculation. Next, the PC register. The PC register means the program counter registers, which is used to store memory address of the instructions to be executed by the microprocessor. As we know that whenever a new thread comes into existence, that thread will get its own PC register on Java stack. And the final subcomponent at runtime data areas is the native method stack. The native method stack are the places where the native methods, for example C language programs, those programs are executed. Native method, it is a function which is not written in Java. It is written in different language, that is in C programming language. Now let us go to the last layer. Last layer consisting of three different subcomponents, that is execution engine, native method interface, and native method libraries. An execution engine is nothing but it is a virtual CPU. It is physical central processing unit that is assigned to a virtual machine. And by default, virtual machines are allocated one virtual CPU. It contains interceptor and also just-in-time compilers. The next subcomponent is in layer 3 is native method interface. It is a programming framework which will enable the Java code running in a Java virtual machine. Finally, the native method libraries. It holds the native method libraries information. This is the basic structure of JVM. If you have any question, please do not hesitate to contact me. My email ID is bijoyparalindia@gmail.com. If you like my channel, please do subscribe, and thanks for watching my video. Thanks for your time. Bye bye.